Animal-based protein sources are acidogenic. They have a higher acid-forming nature. It's widely recognized and often subject to trends that a protein-rich diet is a major positive contributor to several aspects of personal health and fitness. But source, amount, method all play a role in how the body responds to a protein-rich diet, and some foods are just naturally more acidic when digested. Technicalities play a role in the context of long-term effects, such as the relationship between high animal protein intake and dietary acid load. Why should it be considered, and is protein variation important? To clarify, we refer to a prolonged high-protein diet, rich in acid-forming substances, rather than the basic required daily intake. We explore some of these points. First, to define dietary acid load, DAL, which refers to the balance of acid-producing and base-producing foods in a person's diet. It measures how much acid or base is generated in the body after food is metabolized. A higher dietary acid load may indicate that the diet contributes more acid, whereas a lower or negative dietary acid load may indicate a diet that is more alkaline or base-producing. An acidogenic diet, highly acidic, promotes acid production in the body upon digestion and metabolism. However, to differentiate, the body's natural digestive acid response, hydrochloric acid, is a normal and crucial biological process serving several mechanisms like digestion itself, bacteria regulation, defense, etc. But this differs from the metabolized acid produced by acid-producing foods. In chemistry and nutrition, a base is a substance that can neutralize acids and is often referred to as alkaline. So when we say a diet is more base-producing, it means it is more alkaline and can help balance or neutralize excess acid in the body. Yet, it's essentially about the balance between both and not necessarily tipping towards singular alkalinity. Additionally, the body tightly maintains an optimal pH balance as a fundamental state. However, if the acid load remains high over a long period, it can strain these systems. While blood pH may stay within the normal range, this constant compensation can lead to negative side effects such as bone mineral loss, muscle wasting, and kidney strain. So, the body maintains pH but not without potential cost to other aspects. This can translate to poor health and potentially result in chronic conditions, including cardiovascular problems. Despite tight pH regulation, this factor becomes as important when optimizing a holistic approach, with potential renal acid load leading the kidneys to excrete more acid, which can draw buffers from bone, releasing calcium and affecting urinary mineral balance, potentially impacting bone integrity unless buffered with alkaline foods. Sources state that during protein metabolism, sulfur-containing amino acids in animal proteins, namely cysteine, homocysteine, and methionine, generate sulfur-containing acids, sulfates, and phosphates that require neutralization. Sulfates and phosphates are also referred to as metabolic ash or acid ash, which is mineral residue remaining after food has been digested and oxidized for energy. The body is equipped with buffering systems to neutralize acidic conditions. However, prolonged exposure to acidogenic diets may impair this capacity if not supplemented with additional buffers, such as base-producing foods. In response to acid-producing foods, the kidney excretes these acids via net acid excretion, but this process may increase urinary calcium loss. To neutralize systemic acid, the body may reabsorb bone, releasing calcium and phosphate buffers, etc. This may transiently and in the long term influence overall physiological outcomes. J. Weers and others, 2024, state that maintaining acid-base balance is essential for health and diet is a key factor, as foods are metabolized into acids or bases. Dietary acid load, DAL, measures the net acid effect of the diet, considering both acid-forming nutrients, like protein and minerals, and alkalinizing organic acids. Western diets, high in animal protein and processed foods, typically have a high DAL, which can lead to chronic low-grade metabolic acidosis and is linked to greater health issues and reduced lifespan. Any shift in this dynamic balance towards a more acidic environment has been associated with poorer health outcomes, such as cardiometabolic ailments and kidney issues. They also observed that in comparison, vegetarian and vegan diets with high fruit and vegetable content are often low in acid load and high in potassium bases, which can result in a net alkali load. Human acid-base equilibrium, largely determined by the concentration of hydrogen ions in blood plasma, is a tightly regulated physiological system that aims to maintain blood pH between 7.35 and 7.45. As previously discussed, the base or acid-generating properties of food, especially protein, lie largely in their amino acid composition. Sulfur-rich amino acids, such as cysteine, homocysteine, and methionine, found abundantly in animal protein, are thought to be acid-generating as their catabolism produces protons. Whole food plant-based proteins contain amino acids with a net base effect, such as glutamine, glutamate, and glycine. Continuous exposure to high dietary acid load produces excess ammonium, which is a potential cause of inflammation and fibrosis. Furthermore, that a high dietary acid load is associated with muscle catabolism and loss, factors of sarcopenia and frailty, which can affect BMI measurement. Additionally, there is also a positive association between high dietary acid load and various other anthropometric measurements, including an increased waist-to-height ratio, larger hip and neck circumference, a higher fat mass, and lower fat-free mass. Diet is a major determinant of the acid load that the kidney must excrete to maintain acid-base balance. The association between dietary acid load and kidney function is often attributed to a low intake of fruits and vegetables. Some examples of dietary acid load-producing foods include meats, due to their sulfur-containing amino acids, low alkalizing minerals like potassium and magnesium, and a strong positive acidic effect on potential renal acid score. The association of dietary acid load is also interlinked to increased insulin resistance and carcinogenic conditions. Bone acts as the body's storage for alkaline, base, minerals, helping to keep the body's pH balanced. You've probably heard of the alkaline diet, and while that's related to this topic, the real key is balance, not being too acidic or overly alkaline, but maintaining a healthy equilibrium. Of course, other factors like sodium chloride, table salt, also contribute to acid load. Holistically, where prolonged high intake of acid-forming protein diets are consumed, base-forming foods are equally important to help buffer the potential effects of DAL, and protein variation is perhaps a key buffer, based on individual suitability and health status. Thanks for listening in. Do subscribe to the channel and stay connected for more on holistics.